Hi, my folks. Welcome back. We're going to continue our very exciting compound interest unit. And right now, we are looking at the compound interest formula. So this is the version that we're using. And today, we are finding I. And so we're going to look at solving for interest when we know all of the other variables. That will be the first skill that I do with you. The second skill we need for Math 53, and it is all about converting interest rates so that they match up with our payment schedule. So for now, let's start off with a little bit of vocabulary. We know, or we've seen, that there are two words that are used when describing interest. The first is nominal interest, and nominal interest is the amount of interest for the year. And I think most importantly, what we care about for nominal interest is when we do algebra, when we are solving for our answer, that we are looking for I. So we're solving for this I variable. Now, when you see nominal interest, it always talks about how it's being compounded. So an example of nominal interest for the year might be 5% compounded semi-annually. So this would be how we would describe it. The 5% would be for the entire year, but we always also say how it's being compounded. But most importantly for us, when we're doing our algebra, when we want to solve for nominal interest, we are solving for I. All right, now the second vocabulary piece is periodic interest. And periodic interest is the amount of interest for the compounding period. And just like above, we do our algebra, but when we do our algebra, we are solving for I over m. So we're solving for the little piece of the interest for that compounding period. So if I look at this 5% semi-annually, the I over m would be 2.5% per semi-annual period, or every 6 months. So when we're solving for the periodic rate, it's actually taking that 5%, dividing it by the 2 for semi-annually to give us the 2.5% semi-annually. So what we really care about are that we're solving for the two proper pieces depending on the vocabulary. Now I'm going to solve for both of them as we go through the examples. However, when you get yourself into the contrived situation of a math problem and you want to pick the correct multiple choice answer, you're going to need to know the difference between the nominal and the periodic. All right, so let's do an example. So it says a 5-year, $30,000 GIC has a maturity value of $36,680. Calculate the quarterly compounded nominal interest rate. Okay, so this question's asking for nominal. So we're going to want to solve for I, but I'm going to solve for both of them and show you how those two solutions might look. All right, so what do we know? We know that we have a present value of $30,000. And we know that we have a maturity value, which is future value, of $36,680. We know that this is a quarterly compounded interest rate, so that means that m is equal to 4. And we have a time of 5 years because that's the investment period. All right, and we are looking for I. So let's take our compound interest formula. So it's F equals P 1 plus I over M to the MT. And let's substitute in everything we know. All right, so we know that F is 36,680. We know that P is 30,000. We don't know what I is, but we know that M is 4, and we know that T is 5. All right, I can take a moment and just simplify this exponent. So I'll just rewrite this real quick. We know that 4 times 5 is 20. All right, so now we need to do order of operations backwards to solve for our variable I. So we have to undo everything that has been done to the I. And when we are isolating a variable, we are working through order of operations backwards. So what does that mean? Well, we know that order of operations follows BEDMAS. And so when we're isolating a variable, we're going to want to undo all of the things in the reverse order that we would have done them had we had we been performing order of operations. All right, so clearly the last thing that we're going to do, the last thing we're going to get rid of are these brackets. And so we don't have any addition and subtraction. I mean, we have addition here, but it's inside the bracket, so it's considered a bracket. So the first thing we're going to undo is the multiplication. So the first thing we're going to do is divide both sides by 30,000. And that comes out to be 1.2226 repeating is equal to 1 plus I over 4 to the 20. All right, so we've undone the multiplication. Now we have an exponent that needs to be addressed. So we have to undo to the power of 20. Well, how do we do that? Well, we know that if we square something, the opposite of squaring is the square root. So if we have a 20th power, the opposite of that is the 20th root. So we're going to take the 20th root of both sides of the equation. I don't know if I know how to spell that. 20th root. Maybe, maybe not. I don't know. We'll just erase it and pretend that I knew how to spell it. All right, so here we go. To take the 20th root, we need to take the 20th root. It looks like this. And what happens is that these cancel one another out. So how do we find that key on our calculator? Every calculator is slightly different, and we'll go find the NumWorks calculator in just a minute. But typically, it looks like this key here that you need to punch in. And so typically you have to, in this case, punch in 20, hit your X, Y key, and then put in your value to get your answer. Some calculators require that you do that in an opposite order. So let us go check out the NumWorks calculator. I see that I have that X to the Y key, but I do not have the key that I've just shown you on this particular calculator. All right, another option, if you're going to use the NumWorks calculator, is to raise your exponent to the reciprocal of whatever the power is. So you can use your X to the Y key or your exponent key and then take the reciprocal of 1 divided by 20. So those are your two options. On the NumWorks, it appears that we're going to have to use our exponent key. So what does that look like? It will be 1.222, and then a bunch of sixes repeating. We need to put a lot of those in if we're using an inaccurate representation of it. Here's my exponent key. I'm going to put my exponent in brackets, and I'm going to take the reciprocal of whatever my power was. In this case, it was 20, so it's 1 divided by 20 as a power. And press execute, and we get an answer of 1.010102. All right, so try that on your particular calculator. So either you have the option to type it into your calculator using this version, the little X in front of the square root, or if you're using the NumWorks calculator, or any calculator to be honest with you, you can put the reciprocal as a power to take the 20th root. Now, be sure that that exponent gets put in brackets. That is critical for getting the correct answer. All right, so now we can start to undo what was inside the brackets. Inside the brackets, we have addition and we have division. So inside the brackets, we're going to want to get rid of this positive 1 before we get rid of the divided by 4, because remember, we're doing order of operations backwards. Now, this is a positive 1, so I have to undo that by subtracting 1 from both sides of the equation, leaving me with 0.010102 equals I over 4. All right, so here's our first answer. This is our periodic rate. This is our periodic rate because we've solved for I over M, which means that, every quarter we're paying about 1%. Now, if I want the nominal rate, I'm simply going to solve for I. To do that, I see that this says divided by 4, so I'm going to multiply both sides of the equation by 4, leaving me with I equal to 0.040408. This is our nominal rate because I have solved for I. Now, what does this nominal rate mean? It means, like, I'm going to round this. It's about, 4.04% per year compounded quarterly. All right, let's do it again. A $100,000 GIC will earn $40,000 worth of interest over its 6-year term. Determine the semi-annual compounded nominal rate of interest. Alrighty. So what do we know? We know that we have a present value of 100,000. And we know we've earned $40,000 in interest. So what does that mean? Well, it means that our future value is the 100,000 plus the 40,000, the interest that we earned. So our future value is actually $140,000. It's a 6-year term, so our time is equal to 6. And it's compounded semi-annually, so m is equal to 2. And again, we are solving for I. All right, let's take our compound interest formula. So we know that is F is equal to P, 1 plus I over M to the MT. Let's substitute in everything we know. We know our future value is 140,000. Our present value is 100,000. I is what we're solving for. M is equal to 2, and T is equal to 6. All right, and we can clean this up a little bit. So we have 140,000 equals 100,000. 1 plus I over 2 to the 12. Now let's go through the process of working through order of operations backwards. Recall that the first thing that we have to do is get rid of that multiplication. So the first thing always is to divide both sides by 100,000. Or 1.4. The second step is to take the 12th root of both sides, and if we're using the NumWorks calculator, when we take the 12th root, it's going to become 1.4 to the exponent 1 over 12. If you are using any other calculator, it's going to be the 12th root of 1.4. However you decide, whatever tool you have is fine. So let's go into the NumWorks calculator and give that a whirl. So it was 1.4 to our exponent key of 1 divided by 12. And remember, essential, that we put that exponent in brackets. Okay, so we get an answer of 1.028436. So our answer is 1.028436. Let me just redo that. 0.28436. All right, now we're ready to tackle what is inside the brackets. So we're going to subtract 1 from both sides of the equation. And we're left with 0.028436 I over 2. Remember that when we have solved for I over 2, what is that again, my fine folks? That is the periodic rate. And if we want the nominal rate, then we have to solve for I. So we're going to multiply both sides of the equation by 2 for an answer of 0.0568723. This is our nominal rate. And so we can say that, I is approximately equal to 5.687%, or 5.7%, however it is you're rounding it, compounded semi-annually. All right. I would like you to please try the next one on your own, but before you get going, it's a little bit different, so I'll set you up. And then I'm going to let you try the algebra on your own. And so, oops. Let's read the question. Gurpreet hopes to put a down payment of $160,000 on a house in 96 months, but only has $80,000 to invest. Find the annual compounded interest rate that will allow you to invest $80,000 to double in 96 months. All right. Well, what do we have? We're hoping to have a future value of $160,000. And we're starting off with the $80,000 investment. We have a time of 96 months. So remember that time must be in years. So that's going to be 96 divided by 12, which is 8. And we're looking for a compounding rate annually. So this question is saying, like if he's out shopping for a bank and he wants to ensure that he can make this happen, what interest rate does he have to go secure? All right, why don't you stop the video or pause the video, give this a try, make sure that you can do the algebra, come back and I will be solving it for you so that you can check your answer. All right, so you should have written down the formula, substituted in all of the values that we know. Perhaps you took another step to clean that up. Then you needed to divide both sides by 80,000. So when you do that, you're left with 2. You're going to take the 8th root of both sides. And simply then subtract 1 from both sides. So you get that your nominal rate is about 9.05% compounded annually. All right, I think that is probably good. You can look at those solutions online. I do like number 6. So let's make number 6 be our last example together for this first skill that we're talking about, and then I'll start another video for the second skill. So we've all seen those signs around town that offer to give you a payday loan, and they have the, like get, up to $500 payday loan for a $20 charge. And the question is, how much interest are these payday loans actually charging the people that they loan money to? So example 6 says, Money Mega Mart charges $50 for a one-time loan of $500. Find an equivalent interest rate compounded monthly. All right, so what do we know? We know that we've taken out this loan for $500. We know that when we pay back this loan, we have to pay back the $500 plus we've also paid back a $50 fee. So our future value is going to be the 500 plus the 50, or $550. We know that it's for a month, it's being compounded for a month. So our interest, our M value is 12. And our time, the duration of the loan is 1 month, so 1 divided by 12, because of course that has to be in years. And we want to know what is this interest rate that we're being charged. All right. We can substitute everything in. And then we just need to crunch a little. Well, let's clean this up. So we have 550 equals 500. 1 plus I over 12 to the 1. And I'm not going to bother to write the 1, but we know that there's an invisible 1. Let's divide both sides by 500. So this is 1.1 equals 1 plus I over 12. Then algebraically, we're going to subtract 1 from both sides of the equation. And then we are going to multiply both sides of the equation by 12. So it's 10% for that one periodic month, but how much is that as a yearly rate? This is our periodic rate. For our nominal rate, we're just going to multiply that by 12. And we get 1.2 equals I. This is our nominal rate. And so we can see that we're being charged 120% compounded monthly for the loan. Those loan sharks. All right, so come back and I will, in the next video, show you how to do the last skill that you need for Math 53.